All right, folks, welcome to class. We are going to be working on module 4 lab tonight, and let's kind of read through the description here and get a feel for what we're supposed to create. It says, congratulations on your new job. You make 1 penny on the first day, 2 pennies on the second day, 4 pennies on the third day, and so on, doubling each day worked. Write a program that asks the user how many days they worked and outputs the total number of dollars and cents earned, formatted as currency. Do not accept a number less than 1 for the number of days worked. Continuously ask the user to try again until their input is valid. For each day, the output the number of pennies earned, and there's a little sample run down there. So they start with a couple of false entries, right? A 0, a minus or negative number, and then a normal number, and then the algorithm counts up the number of pennies, right? And eventually displays a total. Now, I think we can probably recognize at least one spot where there would be a loop for this right off the bat, right? Remember, this is the grand goal of this lab really is to learn about looping predominantly. It seems to me like whenever you're taking a penny and you're doubling it and you keep doing that, sounds like a repetitive process. So we could probably agree pretty quickly that this is going to be some sort of a loop where we're kind of setting the starting and ending point, based upon, the number that's entered here, right? Well, the starting point is going to be 1. The ending point is going to end up being the biggest number that the user types in. Now, of course, once we get it working right, what's really fun is to put really ridiculously big numbers in and watch it, crank out the values. You guys should do stuff like that because it's a very geeky and cool thing to do at the same time. Kind of like take your computer and see how far you can push it and see if it's really, truly fast and modern. And that kind of algorithm will certainly do it. There's another spot where I think that we could have a loop, though. Does anybody recognize where that loop might be? Feel free to just unmute or type it in the chat. How about this as a possible loop if you're not thinking about it? And this is a really common spot for loops in a program. That is, if the user's entering incorrect information, we can keep prompting them until they enter correct information. That would be a spot for a loop. Now, it's a different type of loop than this one. This one could probably be done probably with a for loop or a while loop. We'll see. We can probably do it both ways, truth be told. But usually the ones that are prompting a user for correct input tend to be while loops almost exclusively, right? And we kind of saw the mechanics of that last time during class. So let's get ourselves ready to work here. And I'm going to pull Visual Studio over, and I do have it over here. I have a solutions file that I use as kind of reference when we're doing this kind of stuff. And this one is in the old-fashioned format. And I say old-fashioned, that's because we can see the entire program structure here. So normally when we're working inside the main method and we're not seeing any of the stuff above it. And John, you and I had a little bit of a talk about that last time after class ended. And is that a big deal? And is that something we should be concerned about? Well, the reality is it is really actually important, but we don't want to overwhelm people when they're first starting out. We're just trying to get you to like walk baby steps, not like go, oh my God, what is this incredible, huge Microsoft complexity here that I'm dealing with? Because that's kind of what it is, right? It is a layering of how your program operates. Truth be told, your program really sits inside of a class structure, right? And you can see here, I have a couple of things that are collapsed down, but I have the first 5 modules of homework are built into this one program. And then all we do to run them is I just change the module number and it runs. I can just call in whichever lab I want or whichever assignment I want by just changing the name right there in the main method. But the way that the main method operates, and this is where we've been doing all of our coding, truth be told, sits inside of a program. And normally we can look at like the module one stuff now, but you could see that we had basically functions that were created that ran the homework, right? We give them a name and they sit outside the main method. And the only way something executes in a program with C# is if there's a function call to it from the main method, or the code is just written in between those curly brackets right there. And just, reality check for everybody. That's what we've been doing so far, is we've been writing code that sits here. We just don't see any of the hierarchy above or below. All the stuff we've done has been sitting here. When I do the example tonight, I'm going to break out of that format and click the little box that we normally don't click to put that infrastructure in. And then I'm going to have basically one project file that's going to run both the lab and the assignment for me. Right. And if you guys want to follow along in that capacity, that's fine. I know a few of you are already kind of aware of how this operates and are already doing it, but this is just to kind of give you, understanding of the actual framework you're playing within. Right. And then when you move on to other levels of C# programming, it becomes really important to work in this format, especially if your program is complex and really is a collection of many smaller programs working together. And that's very normal, especially for a graphical program. You'll write lots of little windowed programs and kind of make them all operate at the same time. All right, so this is just kind of a little sample here. What I am going to do also is kind of show you this little thing, that allows my code to collapse down like this so beautifully. And if you look at this little plus mark in the sidebar, now, of course, you can always collapse down any code in Visual Studio based upon where it sits inside of curly brackets. Many of you have already figured that out by just clicking that little plus and minus there. With the modules, though, the way that they're neatly labeled like this, that happens because I use this special type of comment that's a region comment, and I give it a name. And then if you scroll all the way down through module one stuff, then I put in an end region. And then that allows me to turn on anything inside there, no matter how many programs it is. Now, this is a couple. It's a lab and an assignment, right? Or inside there. I can just collapse those down. And so really what's happening here is there's a whole bunch of code on this page, but I have it, nice and neat. How do I know there's a bunch of code? Look at the line numbers, right? I go from 13 to 67 or something missing here. There's a little bit of code in between, but I think that's kind of a neat little trick, right? So if you have a program that's getting really unwieldy and it's organized into chunks, this is kind of a way that you can kind of collapse it down and look at it all at once in a way, right? And you can navigate through it really fast this way. So this is just a helpful tip. Now, we've been writing programs where it's like 20, 30, 50, 100 lines, maybe, right? But when you get into complex pieces of software, 1,000 lines, 10,000 lines, it could keep going. That's not actually unusual, right? Because you build so many features into your software, you keep adding code, right? And so you need a way to manage it. And this is just a helpful tool, I think. All right, let's get in here. What I'm going to do is I'm actually going to create a new project. And if you guys haven't realized this about Visual Studio allows you, because of the architecture of how it operates, to actually propagate multiple instances of it running. So right now I have a full environment running here, but when I create a new project, it's going to create another full environment for me. So watch what happens. I'm going to do a standard console app. I'm going to give it a name. I'm just going to name this maybe mod for coding. And you know what? I'm going to say solutions from my perspective. I'm not sure if I like the folder it's going into, but you know what? I kind of don't care at the same time. As long as it's in that folder, I can arrange it later. Let's move on to the next tab. And then normally we would check this box, right? Or do we leave this unchecked normally? What's our normal action to pass?
Leave it unchecked.
Say that again, Sebastian.
You do not check that box.
You do not check that box. All right. Now I'm going to check it. I'm going to save. my other stuff. All right. And so notice what it does when I did that. It does give me that whole infrastructure. And I think it's healthy, frankly, that we kind of work in this format here right now today. So I'm gonna allow you to work in the old fashioned way if you want to. It doesn't really change much. The only difference will be that I will create my program code as methods within this larger program that I will then execute by dropping a call to them in the main method. Do you guys feel what I'm saying, right? Any methods I have to create for the programs that I'm creating will also be built on the same level in the program as they normally would be. The only difference is with the main method, just keep in mind that that executes. This is the only thing, anything in between these curly brackets will be the only thing that will run within the program. So if there's no call to it here, it will not execute. So it's up to us to steer the ship. But it's kind of a neat way to run a program at the same time. So let's give it a try. I will remove this console right line for right now because we just don't need it. All right. Let's do a little bit of kind of organizing here in terms of how we're going to build this. And I just want you to think about there's going to be some prompts, right? So I think that's kind of easy stuff to do. And we do have to respond to the prompt, so we're going to be looking for a value. And then as long as the value is not valid, we'll keep asking the user for input. So that's the one part of it, right? And so you might, and I'm just kind of putting this in your brain, whatever your pseudocoding techniques are, and I'm not like trying to dissuade you from whatever technique you use, you could actually just write in the code engine, just give yourself some notes and maybe say something like, first prompt the user for the number of days worked, then check to see if that input is valid. And here I am doing it in Python mode again, right? Set a word. Right. Why isn't it green? Well, now we know why. Right. All right. And okay, so now we're going to check to see if that input is valid. If input is invalid, ask them to input again. And you should add probably keep going, right, until it is. And, if it helps for you to actually say, this is a loop or whatever, you do it, right? So you see how my brain is kind of thinking here, because I could just dive in and start typing this code. And I realize it's not so hard to do what I'm talking about, but it helps to have a roadmap, right? So then you're going to have this input, then you have to come up with the correct calculation, right? So the correct calculation would basically, we can say, figure out how much they made by doubling each day. Okay, that sounds like a loop too. So I might say loop, and you might even think about it like this: loop until number of days entered is reached. Then each time through the loop, double the amount. And this is where we'll get with the amount being earned is what we're doubling. Then add to total. And I might say that sounds like two separate steps to me. and then basically display the results. And if you will, if you look at this, right, the way I've broken it down, and this is really very primitive pseudocode, but yet helpful for how I'm going to solve the problem, right? So I'm hoping you guys are seeing that kind of technique. But we are fitting into the format of input, processing, and output, totally, right? I mean, it fits in there, even if we're using loops. You know, the logic and the looping and the sequence and all that stuff that we're doing is all kind of intrinsic to it. But loops do have this unique feature that they kind of do branching while they're repeating at the same time. So it's really kind of a combination of selection and repetition. And I think that's kind of neat. So I'm just going to kind of leave that at the bottom. And then if I forget what my logic was or what I thought my flow would be, I'll just refer to it. Just as simple as that. And you guys can kind of do the same if you wish. All right. The other thing that I have to do is I am pulling up my cheat sheets, which apparently I did accidentally turn off. Just going to do that over. Let's go figure out where the heck I have them. I apologize, folks. I've lost my file. Good thing I have a backup. All right. Let's start by creating a method. And I'm going to begin here inside of my code. And you see I'm coming outside of that main method to get started here. And I want to make a method that's going to run the whole lab, right? That will be kind of the driver of that lab. And we may build functions. I'm just kind of like debating that all in my head right now. But let's go ahead and do a public static void, and then let's just call it that, and we're going to do like proper naming convention here, mod for lab, right? With parentheses. I don't expect to send any information to this, by the way. So I'm just creating it to run the code, right? If I was returning information, what I would do here is I would include the return types. Normally when we've done functions, we have the return type and the name of the function with the parentheses. Because I'm operating in the larger outer structure now, I have to indicate whether it is public or private. So public means it is accessible inside this program from anywhere and outside this program from anywhere that has direct access to this program file. Static means that it's unchanging, basically, but that's considered required. If public is not included or private is not included, public is implied, by the way. Right. So sometimes you see it, sometimes you don't, but this is considered the correct way to do it. Now, because we do want our code to execute when we hit the run button, if we want anything in Module 4 Lab to work, I have to call it. So I'm going to just call it by name, and I'm going to call it Module 4 Lab with the parentheses and a semicolon. Just to prove to you that it will run, let's put in a console write line. And just do due diligence here and say, hey, whatever. Okay, just to be snarky, but just some words in there just to get it to run. Right. All right. So let's hit that run button and see if the main method will call up the Module 4 Lab. Here comes the run. All right. So it is working. Just to prove to you, if I remove the function call here, in fact, let's not remove it. Let's comment it out, but not in Python mode. All right. And then let's go ahead and run that again. All right. It ran. It just started and it stopped. And it didn't do anything. And you can see the blank line that it created. It just didn't do a darn thing. Right. So that's basically kind of the overview here. So now, if I'm going to write any additional methods, once again, that I want the Module 4 Lab to run, I'm going to put them on this level, basically the same equivalent level as the Module 4 Lab. And then I will be able to call them subsequently from here. We'll see if we take that approach. We might not want to, real frankly. We might not want to. It might be maybe completely unnecessary is a good way to look at it. All right. So why don't we begin by writing some prompts, right? I think that's probably a good place to start. So maybe you guys want to coach me on this. In fact, if we're going to do a prompt, typically we'll create just a write statement. We are already told what to put on the screen, so that's pretty helpful. And I think all right, well, it looks like we should do some console write line right here. What do you guys think? Because they have like a title that pops up, right? Let's do that. That should be pretty simple, I think, right? So salary calculator and a bunch of dashes to match. So my console write line will actually prove useful. And you know what? Let's be clever here and just copy that for right now. Well, it's blank. And then I'm just going to type in the title, salary. And we'll do another write line. And then we'll just do dashes. Pretty slick. In fact, I think what's kind of neat, if you want to go full on ASCII art on this, you can do that. You can even make a little box for it if you want. I know people will totally overachieve if given the opportunity. So I know that's kind of cheesy, but you know what? And then I'll just put in even cheesier, just a blank one underneath. I think that will look better. Now I could, and I'm just putting it out there, I could take that little bit and I could call it print header and just put it in a function and just call it in. That'd be totally a thing to do. I'm not really too worried about it. I think this will work out all right. Now these really should be right lines though, now that I'm looking at it. The prompt should be a right. Nobody caught me on it. You guys are supposed to catch me when I make mistakes. And then I'll try to convince you that that wasn't a mistake. I completely intended to do that right from the beginning. All right, so right here, what we're going to do now is do the actual first prompt. And the first prompt should say, and here's the beauty, we can actually copy it right from the screen. verbatim with the space and the little funny caret symbols there. So enter number of days worked. Now we're going to need to capture this information. Could I suggest that maybe we create a variable called days? Sounds like a logical thing to call it. So we could create it as an integer. Days equals, and now I need the traditional capture that we do, right? And if you guys remember, normally we would do a read line, but we also have to convert it to an integer so we can use it, right? So if you guys are probably kind of getting in the mode now where this is becoming pretty typical, and you see how Visual Studio helps me right along the way with it. Very, very typical. Is it okay that I just declare the integer on the fly like that, right in that spot? Yeah, I would say it's okay. You know, maybe it's not like the most ideal way to do it. You know, if you were really thinking about this, I might suggest that you would put it up at the top here somewhere, but this works too. Okay. All right. So now we get to the point in the logic, and I'm just looking at my stuff here, looking at the point in the logic. It says first prompt the user for the number of days worked. Okay, we did it. Check to see if that input is valid. If the input is invalid, ask them to input again. Keep going until whatever I was trying to say there, loop. So that's why it's helpful to write your pseudocode in a way that makes sense, because when you read back and you didn't type in what you meant, okay, that makes it a little interesting. But there is a caveat, right? Here's the caveat. Do not accept a number less than 1 for the number of days worked. Continually ask the user until their input is valid. All right. So that's what we're working on right now. To me, that does sound like a loop. You might even go as far as kind of start to break your code apart a little bit like this. And I'm going to think about what kind of loop I want to operate here. In fact, I kind of mentioned it like before we got started, like a really good type of loop for this type of situation for user interfaces is a while loop. So I am going to say while, and you know, look at what it's suggesting. I think it's fascinating. I'm just going to kind of go with that because that's not what I want, but you know what? It helped me type it. So, hey, why not? Right. So does this make sense? While days is greater than 0. Okay, so while days is greater than 0, operate. No. I want to operate the loop if what they put in was invalid, right? To prompt them again. This isn't where the functioning is happening in the program. This is to correct the user input. So, all right. So what's the scenario? And you know, if you look at the lab behind us, I left it up on the screen like that on purpose. Do not accept a number less than 1 for the number of days worked. So while days is less than 1, does that make sense? What do you guys think? Right? Because if they type 1, this would be false, correct? Right. This code would not operate. That's what I want. Right. But if it's anything less than 1, so 0 or a negative number, then we want to do what? What is it we should be doing inside the while loop?
Prompt them to re-enter.
Yeah, prompting them to re-enter. All right, so could I just do this again? Let's think about that. Well, yeah, you kind of have to, right? There's one difference though. We don't want to declare days here again. I am going to copy all this code because it's easier than retyping it. But basically, we want to do that. But here, we want to remove the int declaration because it was already declared. Right? So do you guys remember from the lecture when you prompt somebody before you go into a loop? What do they call that? There's special terminology for it. It's not like super significant, but it's something you should know. And basically the terminology is it's the priming read, right? And normally we do that to get the loop to run, but in this case, it's only the priming read if we get the wrong input, but it's still a priming read, right? Because if it does go into the loop, that's the initial one that triggered the loop to run, so it's priming the loop. So do I want to put in a different message? Oh wait, it does say days cannot be less than one. Try again. Okay, I guess yes is the answer. All right, so let's put in that exact message, and I'm just simply going to enter another console right line. Sure, fumbling with that keyboard today. Okay, so put that message on the screen. Then we'll put up the prompt again and grab the input. This should work, right? I mean, actually, okay, suggestion, right? So this is one of the other takeaways from the lecture is let's try this in little bits and pieces, maybe rather than try to run the whole program at the end and then figure out it doesn't work. You see the logic, right? So I can actually prove that this works. And all I'm going to do here is I will take like this, like one of these console write lines here. And after this all runs, I can just put in a little message. Be goofy. It doesn't matter. You know, this is for me or for us, not for the world to see. But for right now, this is enough for me to test my code. All right, let me get this up to full screen again. And let's take a look at what we have. So we have this little display piece, right? And then we do the priming read, create the variable, then we check it. If it's not okay, we prompt them again and capture it, tell them it's wrong on top of it all, right? And then when they finally enter the right number, then this will happen. Then we can write the rest of our code. But for right now, this is just good, right? And this is a really helpful tip, you guys. Don't try to like solve the whole program at once. And it's okay to run it partway along the way. All right, doesn't look too bad, right? Enter the number of days worked. All right, I'll put in 0 because I know that should fail. Okay, very good. Let's do -1 like the example. Let's do minus 2.3. Oh boy, didn't like that floating point number. All right, so that's problematic. Let's try running it one more time. All right, try running it one more time. There we go. So 0, -1, -5, 55. Okay, now that seems to have worked. So now we're ready for the next step. If you wanted, and I'm just kind of putting this out there as, food for thought, this whole procedure here, or at least all of this, you see, I can't help but use this terminology, right? This little block of code, that could be a function. I'm just kind of having you think about this, that just checks the user input, right? This could be a function that just displays the header, right? And then the next part where we do the calculations, that could be a function. And then the part that displays the result could also be a function, right? So you guys feel where I'm going with this, right? Not that we have to write it that way, but I'm just kind of giving you that food for thought. All right. I think what would be good to do next then is take a look at our pseudocode. This message is going to go away, right? We might reuse the right line at some point. I always, in the old days of coding, and this just shows my age a little bit, but I always used to put one of these at the end of my programs, especially if I wasn't sure that they were ending, especially as you throw loops in and they would run forever. And it was very reassuring if I would leave it at the end of the program. Oh, it worked. I made it all the way to the end of the code. It didn't fail heroically. All right, but in here now, we need to kind of do, um, the math and the processing. If you wanted, I'm just putting it out there. That's the next part we're going to do. And then so sort of grabbing the pseudocode kind of stuff, but setting up a framework for myself to drop the stuff in, right? This is a strategy that I think is helpful. You may not find it helpful, but I will tell you that I think that people who tend to organize their code like that tend to be more successful more consistently, and with less errors typically. So, all right, this is going to be kind of a little bit of a repetitive process, right, to calculate the pennies earned. And let's look at how this works. Figure out how much is made by doubling each day, loop until the number of days entered is reached. Each time through the loop, double the amount being earned, then add to a total. All right, so to me, it sounds like we need some way to total stuff, right? So we probably need a variable that will hold, the total, and probably need a variable that's going to hold the current amount. So maybe I just come up with two variables, amount and total. Does that seem reasonable to you guys? I think so. All right. Now, what data type should I make those variables? What do you think?
The total could be a double.
Okay. All right. Let's go back and look at their output because there's a little bit of a hint here, right? We're talking about the numbers of pennies earned. Right. Okay. Right. So if you're catching kind of like, how many pennies are earned on each day. All right. Well, there's also this thing that happens too, that apparently they're not showing day 9. I think that's kind of interesting, but they are showing the total, right? Or is this the total of all of these combined? Yeah. That's what it is. Because 128, so all the previous numbers, when you add them together, will add up to the last number. So all of those add up to 128. Isn't that fascinating how that works? These are like mathematical patterns. All right, whatever. But we are going to go from pennies, where we have 128 pennies or 255 pennies. Then we also have to convert that to money, which means we have to move the decimal place over twice. Right. So there's going to be an additional calculation I didn't even anticipate. Right. And then we have to format it for output. We can do the formatting for output, maybe even the adjustment of the decimal point, maybe with the display part, but maybe the moving of the decimal point will happen up here. So I'm just going to put a little note here. Don't forget to move the decimal place over by 2. Which direction? To the left, right? All right. So I'm just putting that note in there, so don't forget, so we don't have like, 255 pennies equaling $255, which is incorrect. All right. All right. So I'm just looking at the clock right now. I think this is a really great spot to take a break before we kind of go on to the next part of this. So let's do a 5-minute break. Let's call it 7:45 and return at 7:50. All right, so I'll pause the video and I'll see you guys in about 5 minutes or so. Okay, we're back from the break and we're gonna press forward on this and hopefully finish it off here. Just before we finished up writing this while loop, we talked about the fact that we have to keep track of how much we're grabbing, and we talked about what kind of variable is appropriate for doing that. And I think we could probably all agree that a double seems to make sense. Whenever you're dealing with money, it's probably a smart move to do a double. Now, truth be told, with the pennies, I mean, it's not really absolutely necessary. The concern is later when we do math to get to the dollars and cents, right? That's kind of more the concern, right? I think we talked about creating one variable called total. Probably smart to set it to 0 to start with, right? We don't want to start with money. And then I'd like to create another double called, well, this is what's keeping track of the pennies, like how many pennies I currently have. So, I mean, I could call it pennies. I could call it amount of pennies, or whatever you think is appropriate. But just for the heck of it, I'm just going to call it pennies. Sounds good to me. And how many pennies should we start with? Well, here's a separate question. Should I start with 0 pennies? Well, we're going to start with 1 if we worked one, like the first valid input, think about this, has to be 1, right? Because anything less than 1 isn't going to be allowed. So, hey, we could start with 1. That's okay. Now, let's use these to solve the problem. There's a couple different ways we can do the math on this, and some of it is really kind of dependent, real frankly, on your exposure to both like math libraries and programming, if you've done this before, or when you recognize the fact that we're simply doubling, well, that's times 2, right? So you don't have to use any fancy math libraries to do this. However, there are some that are available that might be considered for use. All right, let's first think about what type of loop we want to put together, and then what's the syntax for it. Well, I can tell you what most programmers would do in this situation. This sounds pretty finite to me, right? And controlled, because once we get past this valid input thing, I mean, we know we're going to have valid values to work with. So it's going to be 1 to something, right? And just listen to the way I said that. So we know that we're going to start the loop at a certain spot and then check it each time through, right? If you guys are feeling where I'm going with this. Now, do I need to use a separate variable to keep track of the loop is the other place my brain goes. And you know what? I think that's wise in this situation, right? So you may or may not agree on that. All right. So now I'm thinking why this is wise is because I don't want to use pennies if that's what popped into your head, just because it starts at 1, because this is going to keep changing. So like one day it's 1, next day it's 2, next day it's 4. So it like breaks sequence really fast. So we don't want to use that one. So having a separate counter variable, I think, is really important. So I'm just using I, and yeah, I'm starting at 0. Right. Then, and I love that this just like automatically recommends what code I should type. And it almost kind of makes me maybe a little miffed that it's exactly correct. If you guys look at this is exactly the code I would write. So this tells you something about the intelligence engine built inside here. Yeah, so as long as I is less than days, and let's think about the scenario really carefully here. If the person inputs 2 as the number, right, this will start at 0, right? So that's less than days. So 0 is less than days. So it'll do whatever it does. It'll double it. It'll go from 1 to 2. And then the counter goes up to 1, right? It goes from 0 to 1. And then is that less than days? Yes, it'll do one more iteration, which is what it's supposed to do. But when it comes back through and it becomes a 1, it is not less than, well, then it becomes a 2 and it's not less than 2. right? So you see kind of the logic there. So we're offset by one, and that's why it works. You could set this, if it makes more sense to your brain, you could set that to one, but then that would have to be less than or equal to, right? See the logic chain that goes with it. So whatever you're comfortable with, you could literally write either logic. That would be fine. All right. So I think about the fact that, all right, the message that we're supposed to put on the screen. So this is the other part. This would be a really common thing to miss, by the way. Really, the first thing that should happen inside this loop is to output this, right? Because I don't want to double the pennies until after I put that message on the screen. So I'll say pennies earned on day one, then double it. And the next time I'll show what was doubled. So we know we're going to use this text, right? So I'm going to copy it. Let's go back and add that in, and that can be as a console write line. And let's put in copy pennies earned on day one. And then could we do a little string interpolation here? I think that would be wise, right? Now, I want you to think about this as the correct logic here. What should go inside the string interpolation? Should it be I? Some people are nodding. Okay. I don't know if you're just, I don't know if you're, and I'm not trying to trick you right now. I just want you to think about it a little bit, right?
Isn't I your day one? Wouldn't you want to display I as day variable?
Yeah, there's something I'm missing here too, and I always forget to do this here. What do I have to put at the beginning of the line? That the dollar sign. Right. But John, I'm trying to follow your logic here. So my brain tells me to do this. Let me show you why. So I don't want to hard code the number of days. This will be the number of days. It will always be 0 plus 1, right? So whatever I is going to start at 0. So I'm going to add 1 to it each day. So pennies earned on day 1. We'll do that programmatically rather than, I don't want to hard code that. Oh my God, no, I don't want to hard code that. I want that to automatically update. But after here, this is where I want to show. What is it I want to show? Think about it. What should go inside here? Pennies, perhaps? So pennies earned on day 1, pennies, which on the first iteration will show 1. These will each show 1. Now, here comes, maybe, and I'm just going to put in this little argument here. Maybe I could switch this to I and actually make that 1 to start with. I could do that and then change that to a less than or equal to. That would work too. If that makes your brain sit a little more comfortably, you could do it. Right. I'm not going to rewrite it. I just don't want to. So what's the next thing that's going to happen? Whatever the pennies are, we want to add that to the total. So and see, it's auto-suggesting again, and it's scaringly smart, right? I don't want to read in from the read line though. I just want to add pennies, whatever pennies currently is. I just want to add that to the total. First time through, it'll be 1. But then I also have to double the pennies. So pennies would become, and boy, it is just so darn smart. It scares me. I'm going to show you this approach first. Pennies would become pennies times 2, right? just nod and smile. That is the correct answer, right? You know, that would be the one way to write it. Okay, so that's one way to write it. And so this is kind of the goofy teacher in me. Kind of have fun with it a little bit. So that's one way. The other way to write it, and probably the way that I would actually recommend, is to do this. And when I first started typing it in, it was like, I'm like Visual Studio. It's like, oh my God, it's blowing my mind how smart it is now. The 2022 version is kind of crazy. Thank you, AI. Right. But yeah, penny times, isn't that the same as this? It totally is. Yep, it totally is. I can show you one more mathematical way to do it. And I'm just going to kind of bring this over and just show it to you. This comes from our solution file. I'm just pasting this in. This is not what you should do, but this is another way you could do it. So imagine this is called pennies, right? You can also use the math power function to take and raise something to the nth, where nth is the loop iteration. Yeah, so this is probably a little bit more complicated. And because it's just doubling, it kind of seems silly to me. I'll be real frank, right? To do a math power thing. So I'm just showing it to you though, just so you guys are aware. Okay. Is there anything else we need to do in the loop? No. Right. Now, I would kind of argue, and this is kind of like, if we wanted to display exactly the same way, because and it'll say on day 8, but then the real question is how many in total, which is adding all of them from each day. Okay. So I think our loop is just done. I don't think there's anything else to really do. Now we just have to do this. Piece of cake, right? Piece of cake. But remember my little message here. Don't forget to move the decimal place over by 2 to the left. All right. I'm going to delete this so I can forget it. Kidding. It's firmly in my brain. Plus, I have a cheat sheet over here that tells me exactly what to type. So I'm okay. So I'm just going to drop in my final output line here, you guys, and then show it to you. All right, so there it is. So we'll do a right line. I'm going to say the total using string interpolation again. We're dropping in total, dividing by 100. That's how you would move the decimal places over 2 to the right. And think about this. Dividing moves the decimal place to the left. Multiplying moves it to the right by adding zeros. Kind of clever. Helpful little math trick though. And then of course the :C formats it as currency. So $, commas, periods, 2 decimal places after the period. Makes it look beautiful. Right. All we need to do at this point is to execute this code. I'm going to zoom out, right? So we can see kind of all the code at once. And then, kind of sort of strategically see the main method all at the same time. Right now, the main method is set up to call the module for lab. Right? Are we ready? Let's do it. All right, here comes the run. All right, so there it is up on the screen. Let's try errant input first. We know this works because we've tested it before. Now we use the same numbers they used, which was 8. And there it is. So did we get the exact same stuff on the screen? It looks exact. Oh, I put an extra space here at the top, but yeah, I'd say this is complete. Now I might, do a couple of things to pretty it up, real frankly. Like I might put a little space above all the pennies stuff, and I might put a space under when the pennies, and this is all beautification stuff. But I think about stuff like that, because my primary coding area is web. So I'm always thinking of what it looks like, And I'll tell you what, users appreciate that typically. You know, if it looks clear on the screen, that's helpful, right? And you can see I intentionally filled the bottom of the screen with my exit code so I didn't have to look at Microsoft's, right? Be kind of nice if it didn't have that stuff on there. Yeah. Exit and we're out. Did you guys all get it to work? Okay. All right, so that was the module for lab. Let's now jump over to the assignment and see the definition for that. And then we're going to follow the same format we've been following, where I kind of put you in the breakout rooms and we just kind of code through, and then reconvene and look at the solution. And so far, you know, our time is going great. So I'm hoping for an early night tonight, right? Like fingers crossed, right? We'll see. Let's talk a whole lot less and get to coding, is what you guys are saying. Right? Let's go over to the assignment. And let's read through. It says, write a program to count the number of even and odd numbers from a series of numbers whose starting and ending number is provided by the user. Okay. So apparently we're going to prompt this starting number, ending number. Okay. I think we can handle that. The starting number must be less than the ending number. Okay. So that sounds like we're going to have to test for that. Right. So like we'll have them put in a starting number. You know, there's some like interesting logic steps that we might want to consider here. So we'll think about this. But we certainly have to make sure that whatever number they entered first is smaller than the number they entered second. So there's going to be a logic test there, and you can imagine a loop to take them back to re-enter. The program should continue asking the user for a valid ending number until it is larger than the starting number. Okay. And they tell you the logic right here. You know, it's just a matter of applying it to code. It also says the range is inclusive. The starting and ending numbers should be tested and counted as part of the series. Okay. So look at the sample program runs here. So start at 2, end at 10. There are 5 even numbers and 4 odd numbers. And is that true? Well, you could write them out or type them out and just take a look. Right. So the really nice thing about those is, you know, they're kind of on your keyboard, right? So you can go like, let's see, between 2 and 0, there's 1, 2, 3, 4, 5 even numbers and 4 odd numbers. That's correct. Right. So we should test with a really simple range of numbers like that we know the answer to. This would be a correct answer, by the way. So we can test with the numbers that are given just to make sure. All right, so let's look at the second run. Starting number 5, ending number 4. So an error message, ending number must be greater than starting number. Then 5, nope, must be greater than starting number. Then 6, then there was 1 even number and 1 odd number. Makes total sense. Right, and what we'll do is we will test with these values first. Absolutely. All right. You know, I'm thinking of one thing that we didn't do with that pennies program, and I really am tempted to go back and just kind of do it. Can we? When we ran this, we just used the given value of 8. We didn't push it, right? Like, so we used 8, and it was like, oh, okay, that's great. But what if it was 888? How much money is this person making? Yeah. It sounds like, man, I don't want to get paid a penny a day, but it doubles every day. Well, after 888 days, you're so rich, you're the richest person on the planet. How about that for an algorithm, right? Because every day it doubles, right? And these numbers are, I want you to notice, this is 6.5 whatever times 10 to the 209th power, meaning with 209 zeros after it. You know, so these numbers are huge. And you know what? The buffer can't even hold all the output in the console. The console can't show it all. Isn't that mind-boggling? And you figured 888. Oh, that's nothing, right? No, that's like I don't know. That's hundreds, thousands, millions, billions, trillions. We're talking world, the whole world's economy by the time we get out here, that's an insane algorithm, by the way. So if anybody ever promises to pay you like that, you say yes, I will take that money, please. Just thought we would have a little fun with it. All right. So I think that this is going to be kind of not that bad. Actually, I don't think there's going to be as much code as you guys think. If you are coding along and using the main method, what you could do at this point is you could use the same technique that I had in my solution file, and you could put in a region and call it module 4 lab. And then, of course, at the very bottom of that, so on the same level, right? So you can see it right here. And that's the easy way to do it. And you just put in your pound sign again and say, and region. So there you go. And then what that gives us ultimately is this ability to collapse the code down like that, and you might find that marginally useful, but I just think it's kind of a neat little technique. All right. So now we're going to do the.
Can I ask a question?
Sure, John.
So how does that look like in File Explorer? So when you go to submit your assignment, do you get 2 program.cs files, one for each region?
Yeah, no, you do not.
Okay, so how do you grade that then? Because you're going to be running double the code.
Yeah, that's a good point. Here's what you do is when you turn it in, right? I mean, that's a really good point. It makes it a little bit less convenient to turn in, but you could just turn in the same one to each, and I will know to look for it. Right. And that is a really notable point. I didn't even think about that, John. I thought it was more important to teach you about this feature than it was to worry about that. All right. All right. So I am going to collapse this region down because we don't need it in our way. And then I'm just going to come down here. I'm going to go ahead and create a new one right away. So I'm just going to do that. So I'm going to create a region. And this one will be called module 4 assignment. John, you could, and I'm just putting it out there, you could just start a new project and do that if you want. That's possible too. And we'll do the end region there. And then all our stuff will go inside here. Now, once again, we are going to create a public static void, and then we're just going to call it mod 4 assign. That's what I'm going to call mine, with parentheses and curly brackets, and then all my code for that's going to go inside here. All right. I'm going to get rid of this goofy pseudo code down here, and I'm going to skip doing that for the next exercise. That'll be on you guys to do that if you find it helpful. So I'm just trying to get you set up to run. So to run it, then you want to make sure that you put that up there. You could, by the way, run the one program and then run the other. You could do that too, right? And so what I mean by that is for now, because I also have mod, let's not have it commented, mod 4 lab. Oops. Like that. So if I did this, it would first run the lab we just did, then run the assignment we just did. But, and here's the thing, for now, while you're working on this, just comment the one out. And then you could also, and I'll show you this trick later on, you can also put in a little message here in the main program body that's like, lab 1 is now done, press any key to run the assignment, and we can do that with the simple read line command. It wouldn't be very difficult. But for now, this is what you should have set up if you're using this namespace, class, main method structure, like if you were following along and you want to be successful in this next part. So I made a region for module 4 assignment, a method for module 4 to run that code, and then put a call to it up here so I make sure it executes when I hit the run button. Right, that's just to kind of set up the whole thing. All right, I'm going to set up some breakout rooms and I'm going to send you guys in, and then I'll let you guys get working on it. And then in the interim, I will code through and record a solution as you guys are working in your breakout rooms. And then I will come in and check with you guys one at a time. All right, so I'm going to pause the recording here. All right, well, now that everybody's in the breakout rooms, I'm going to code through the solution here, and I'm going to kind of do it in sort of like a hurry up fashion for efficiency, basically. We are going to start by going back here really quick and just looking. So we do want to prompt them to say starting number, ending number. It looks like we're just going to capture a couple of integers. So that's a pretty easy process. Overall, let me just get the right Visual Studio window up here. So here comes the prompt for the starting number. And I'll just kind of zoom in on it a little bit just to make it easier to see. And a prompt for the ending number. Right. So regardless of what that starting number is, and I just want you to think about this logically, there's nothing that said it can be negative, right? So it could be any negative or positive number. The only catch is the ending number has to be bigger. Doesn't matter what it is. I think I'm going to beautify mine here a little bit. So I'm going to add another right bracket there. The other thing I'm going to do is, and this is the ASCII art fool in me, I guess, try to make these look a little more even when they're on the screen. All right, so that's me being overly user interface concerned. The next thing that we're going to do is we are going to set up a while loop to do this. So I'm just going to start by typing in while, and now Visual Studio again is recommending stuff, but that's not necessarily accurate, is it? All right, so think about this. What I want to happen now is if they put in the wrong information, I want them to be reprompted again. And while this logic that pops up here is almost like, hey, well, as long as it starts less than end, well, that's kind of what we're shooting for. However, we want to look for the inverse of that. So actually we want to flip them around. So we actually want to say while end is less than or equal to start, then we're going to execute the process of reprompting them all over again. So first we'll start with an error message. There's the error message. And then we'll just go ahead and reprompt them to re-enter the ending number. So you can grab basically your statement from above, remove the integer declaration, then you're all set to go. Next, we're going to start counting, if you think about this, the even and odd numbers in between a series of numbers. And you know what, if we're counting things, we need some integer variables to hold them. So I'm going to set up one for even, and we're going to set that to 0. And I'm going to declare another odd and also set that to 0. And I do want you to notice, we haven't done this much here in class yet, but basically I'm declaring both integers at the same time, separated by a comma, and setting a value. We can do that, right? They're all integers. I could put on 10 more if I wanted. This is just a more efficient way to type it out. So we use the while loop to make sure that we had the right entry. Then we set up a couple of variables to hold our, whatever we count. And now we're going to run a loop. And when we're running from one point to the next, we kind of have predefined parameters. So we can kind of probably smart, honestly, to use a for loop in this situation. And I'm going to set up an index variable to kind of help guide us through, and you see it's suggesting 0. And you know what? I don't know if that really makes sense, because ultimately I want to go from whatever number we're starting at and up to the number we're ending at. So maybe I should set this to wherever start is. So that's what I'm going to do. And then, and I love the suggestion here, because you know what? I'm just going to accept it for the most part. The only caveat is I'm going to add an equal sign here, because I don't think otherwise it'll work correctly. Because if the right, we want to hit that number, right? Okay, so I'm like thinking through the logic in my head. We want to increment up to that point, so we have to include it, because it did say inclusive, so that would make it inclusive. All right. So now we're going to split our curly brackets here. I'm going to leave them in like C# preferred mode. All right. So every time we go through here, we're going to take whatever number we're currently at, which is going to be I, right? So we started at the starting number, but it's going to be I. And we're going to check I to see if it's even or odd. All right. And if you guys don't remember this one, if I want to check to see if something is even or odd, I take that number, mod it by 2 or divide it by 2. And if it has no remainder, or the remainder is 0, basically, then we can increment the even counter, right? Else we'll increment the odd counter. And yes, these are singular statements, so really, you know, I could remove these, so I'll do that, right? Because I will get people that'll say, hey, you know, why'd you go all that trouble typing this in? But yeah, I guess a lot of programmers would do it like this, just because of the visual space that it saves. And you know what? It's still valid code. I'm just always cautious with those curly brackets, because man, that can really mess up your day if you're not being mindful of them. But here, it's like if it's divided by 2 and the remainder 0, we know it's an even number. We just add 1 to the even counter. Otherwise, it has to be odd, and we loop again. The number goes up by 1. And just keep going until we reach that end number. We will run the end number also. Then it'll increment 1 beyond it, and then we'll pop out of the loop. And then we just have to do a couple of little output statements, which I'm just going to copy paste in here. And notice, pretty simple logic, really. So we do the console write lines. We are string interpolating. We're just dropping the number of evens that we counted and the number of odds that we counted, and we're just putting it up on the screen, and that does it. That's the whole program. Now, because we're operating in this you know, hierarchy structure, remember, if you want this to run, you have to hit the or not hit, but like make sure that you're calling that module, whatever, you know, or that function, excuse me. Our module 4 lab is still there. So when you're turning it in, you know, you can alternate these two. And then ultimately, I'm going to run a little bit of extra code in here to show you how you can pause it basically between the 2 program runs if you want to do that. All right, so here we go. Here's our run. Here's our window. So let's put in a starting number. I did want to use the numbers that they suggested, which were 2 and 10. So here comes 2 and 10. And is that the right output? Exactly the right output. Then let's try this. So starting number 5, and then we'll do 4, 5, 6. All right. So let's try it again. Fumbling with my windows here. All right. So we started at 5. We put in 4. All right. We put in 5. Then we put in 6. All right. And there's the correct output. Now, one thing I'm noticing here is I don't like the way that these look right here. You know, so this is me being persnickety again. So I am going to go fix that, by the way. I just like stuff to look nice, basically. I think that'll look a little bit better. All right, it's very simple little tweak. All right, so now that we have that working, let's go ahead and run both of these programs in sequence. So I'm just gonna kind of like load them up like this. I'm gonna hit the button to run. So if you remember, number of days worked, and we'll put in 22. There you go. And it just goes right. And you see this little thing that I put in here, press any key to exit. Well, you know what? Not appropriate, I guess, right? We can just say program complete is probably the right thing. Then here we're going to put in our starting number, and let's put in 45, and then let's go up to some bigger number, right? And hopefully that's correct. So you know what? I not really much of a need to put in a pause point here, but if you just want to like think about this, you can just put in a console read line in between programs. So you could write a message saying something to the effect of like, program 1 complete, press any key to run program 2. Right? Just drop that in here, and you just do a read line. Just don't capture it. It'll move to it. So that is the solution here. I am going to pause the video here once again. And then if the students come up with any interesting solutions, we will take a look. But now I'm kind of going to go back on what I just said. I'm not going to pause quite yet. I did want to demonstrate one other thing here that was an alternate solution that we had for the lab assignment above. And I'm just going to bring it onto the screen here. So I had this code open separate. Here's the variation on the module for lab. And what's kind of interesting about this is it still does the output of the calculator. Days is declared separately, but this is the statement I really want to point out here, which is the try parse command, which is a little bit different than the approach that we used, which was if you look back here, the standard convert to int 32, and that's been serving us well. It works just fine. However, this alternate approach, what's kind of interesting about it is the fact that, right, when we're capturing days, right, this is kind of a little bit of a different thing. So we are going to convert basically to an integer whatever comes out of that read line. And the way this try parse works, and I'm just going to hover over it for a second. Here, let's do it like this. And, oh, it's not part of this. Okay, it's not part of the solution, which is why it's not like IntelliSensing for me. But basically what this does is it takes the read line, this will convert it to an integer, and if it fails to do so, it sends out a message of false. Otherwise, it will output the data to the integer variable days. That's how this command works. So this is maybe a slightly more modern way, but because it does the it's kind of an alternate way to capture the information that's a little more, let's say I don't know if it's necessarily more efficient, but because it returns a Boolean value, if it fails, it allows your program to not stop, if there's errant input. So that's just kind of a little technique I want to show you guys. And so you'll only see that if you watch this video. I don't think I'll have a chance to talk about it in class, but there's that alternate solution for the module for lab. All right. I'm going to pull that back off the screen, and video will get paused.